so let's look at straight line graphs. Now, a lot of people think straight line graphs are way harder than they actually are. So I have got this summary sheet for you to look over. So my class will already have this sheet. I had written this out for them like whenever we were doing this the first time round. But if you are not in my class, then it might be a good idea to either pause this video and write down what I have down here, or after watching this, do your own version of a summary sheet for this. Because with straight line graphs, the big thing you need to know is that all straight line graphs will have an equation that is in this form here. So y equals mx plus c. So the m and the c will both be numbers. So it could be like y equals 2x plus 1. Y equals minus 5x plus 14. Yeah? The y and the x refer to the y coordinate and the x coordinate. So you can always figure out any point on this line. If you have the x coordinate, you will then be able to figure out the y coordinate. If you have the y coordinate, you'll then be able to figure out the x coordinate, because remember the m and the c are just numbers. Okay? Now, what is really cool about this is that this one little equation can tell us so much information. You can tell I secretly love straight line graphs, can't you? And I think the reason for that really is because they come up a lot in physics as well as maths, so they are super useful. If you can nail this topic now, it will really help you in a lot of your GCSE subjects, not just maths. It will really help you in your sciences as well, in particular physics. Obviously that's where I'm thinking about selfishly. Now, let's have a look at what all these things mean. So remember I said the m in this, the number that is in front of the x, that tells you the gradient of the graph, and the gradient is just a measure of how steep it is. So for example, if you have, pretend my pen here is the line on the graph, so a graph like this isn't very steep, but one like this would be really steep. So the one like this would have a higher number in front of the x than the one that was like that. Okay, so the number in front of the x tells you the gradient, and the gradient tells you how steep the line is. Okay. Oh, the higher the number, the steeper the line. There's different ways that we can calculate the gradient. So I've got these written out over here. So this, I would always say to my classes, this is the mathsy way of doing it. This way will always work, will always get you the right answer. Okay. Whenever I am doing this in physics, I probably am more likely to do one of these two, but there's something that can catch you out if you're doing this. So this way here will always work. So y2 minus y1 over x2 minus x1. Now you might be thinking, what on earth are y2 and x1 and all of that? Well, x1, y1 is just a point on the line, like that's the x coordinate and the y coordinate. So we've called them 1, that's the first point we've chosen on the line. And then x2, y2, that's another point on the line. Okay. Now the reason I say that this one will always work is because this one will tell you, if you do the maths right obviously, whether your gradient has come out as a minus number or not, right? These other two are just different ways of doing this, but if you're not super careful with these, you might end up accidentally writing down a gradient as positive when it should be negative. Okay, so these two kind of have to be used in conjunction with these, which is why you have to be super careful if you're not doing this version, right? I think deep down this is my favorite, but in reality I maybe use these ones a little bit. And do you know what? I probably write this and then go on ahead and do this, if that makes sense. Right, I'm rambling, I need to get on. So I've sketched out a couple of wee graphs here, so you can see that this graph is, if you're moving from left to right, is going up the way, right? So a graph like this will have a positive gradient, and this one here, if you're moving from left to right, it's going down the way. So a graph like this will have a negative gradient, right? Now, if you're just using gradient equals rise over run, and you're just doing this. These two are basically the same, so the difference in the y coordinates divided by the difference in the x coordinates. By that I mean, say I'd picked a point here and a point here, and I'd figured out the difference in the y, so whatever this y coordinate was and whatever this y coordinate was, and got the difference in those two, and then the difference in the two x coordinates. If I'm not careful there, this one should come out as a negative gradient, but if I'm not careful, that could come out positive, so I need to conjoin, is that a proper word, my knowledge of this with this, which is why my best advice is to always use this. Pick 2 points on the line and substitute your numbers into this equation. Okay, I've rambled on about the gradient enough. Let's move on to C. So the number that is on its own, and whenever I say on its own, I mean it's not involved with the x, it's not multiplying by the x, or it's not divided by the x or anything like that. It's just a number on its own, and it can be plus or minus, right? So the number on its own tells you the y-intercept, and the y-intercept is just the point at which the graph crosses the y-axis. Now, not all graphs will have a value there, because if your graph crosses through the origin, which is just the point 0, 0, then the y-intercept, the point that it crosses the y-axis, is 0. So it's just going to be in that form, y equals mx. Now technically it's still in the form y equals mx plus c, it just happens that c is 0. Okay, so if there's no c value, your graph goes through the origin. Now the reason I go on about straight line graphs being so handy and this equation being so amazing is that you can actually plot a graph really, really quickly just from this equation, or you can take a graph, figure out the gradient, and that will give you some other value. Now I've slipped a wee bit into physics there, but it is really, really useful. So if I was you, I would be doing out my own version of a summary sheet like this with all the information. But for now, I'm just going to go through and do a few little examples with you, alright? Okay, so here's our first example. These might be in a slightly random order, but we'll see how we get on. So one thing you need to be able to do with a graph is to draw the graph. If you're given the equation of the line, then you need to be able to draw that graph. Now, do you remember I was saying about how these are really like the x coordinate and the y coordinate? That some people don't understand what the equation of the line actually means. It just means that every single point on that line, this equation will apply to it, and this is the relationship between the x value, or the x coordinate, and the y coordinate. Now, the first way that you can draw the graph, if you're just given the equation, is to do a table of values. So I would always draw out my x coordinate and then my y coordinate. Now, Miss Moni's going to kill me because I'm not using a ruler here. Sorry. Now, you need to pick at least 3 values for your x coordinate. Generally, questions will give you a range. They'll say like, pick your x coordinates between like -4 and 4, or -2 and 2, whatever it is. They'll give you a range of values that you should choose. But you can't only choose 2, because if you think about it, if you have 2 points and one of them is wrong, if you're only drawing 2 points, you're always going to be able to join them with a straight line. Whereas if you have 3 and one of them is wrong, then you can't join all 3 with a straight line. So it's a good way of checking that you've actually got it right. One little sneaky thing I do is I would always choose 0 as one of my points, because it makes it nice and easy. Right, so I'm going to choose -2, 0, and 2. Now, loads of people don't like this step because they're like, well, where did these numbers come from? But you just choose whatever values you want. Everyone in the class could choose different values, and everyone could draw the right graph, right? It's fine. Now, then I'll say, right, whenever x is -2, I need to find the corresponding y coordinate, right? So whenever x is -2, my equation for my line is y equals 2x minus 3. But I have said here that x is -2. So y is 2 times -2 minus 3. So that gets me 2 times minus 2 is minus 4, minus 3 is minus 7. That gives me minus 7. Whenever x is 0, y is 2x minus 3. So y is 2 times 0 minus 3. 2 times 0 is 0, so it's just minus 3. And then when x is 2, that was my third point I'd chosen, I have y equals 2x minus 3. So 2 times 2. 2 times 2 is 4, take away 3 gives me 1. Okay, so these are my values now that I'm going to be plotting. So these can go together. So I need to plot the coordinates minus 2, minus 7, 0, minus 3, and 2, 1. So I'm just going to sketch my axes here and then we'll get on and draw the graph. Right, so you'll notice my laziness with not using a ruler did not go into drawing my axes. Always use a ruler for that. If you try and do graphs without using a ruler, it'll just be a complete nightmare. Okay, so the first first point I have to plot is minus 2 minus 7. So minus 2 minus 7. So that's there. 0 minus 3. 0 minus 3. And 2, 1. So 2, 1. So I've got my 3 points plotted. Now all I do is take my ruler, join them up, and get a nice straight line. Now I don't just join the 3 points together, I extend it on for like the full set of the axes. Oh, I've missed out a wee bit. It's not a great example there. Oh, sorry. And always label your line as well, because if you're doing a question and you have 5 different graphs plotted on the same set of axes, it's going to get quite messy. So label it. So this is the line y equals 2x minus 3. And remember, that just means that every single point on this line, the y coordinate is going to be 2 times the x coordinate, take away 3. Right, let's look at the next example. Right, so for this next example, I know it's a very similar question. So y equals 5x plus 6. So for this, I could do the exact same method I did for example 1. And if you like that method and you're happy with it, stick to that. But I just want to show you another way that you can draw these graphs, knowing what we know about the equation. So remember, we know that this is in the form y equals mx plus c. Yeah? So that means that the gradient of this line is going to be 5, which means it has a steepness of 5, and the y-intercept is 6, so we know that it's going to cross the y-axis at 6, so we know that it's going to cross the y-axis here. Okay, now a gradient of 5 means that for every 1 you go across, you go 5 up. Now be careful that you don't just count the squares. I have intentionally here chosen different scales just to prove this point to you. So if you notice on my x scale, I've used 2 squares for 1, and on my y scale, I've used 1 square for 1. So be super careful that you don't just count squares for this. Use the scales on your axes. So a gradient of 5 means for every 1 you go across, you go up 5. So on I'm going to take this point that we've already marked on from the y-intercept. If I go across 1 on my x scale and up 5, so 1, 2, 3, 4, 5, that means my next point is going to be there. Okay, that technically is enough. We could just join those up with a ruler, but I'm going to go the other way as well. So 1, 2, 3, 4, 5, that's going to be a wee point there. Right. Now I can join all my points. Now, some people like this method of drawing the graph, some people don't. One of the reasons, I'm just labeling it here, one of the reasons people like it is that it is quicker than doing that table of values. But, oh my goodness, look how messy that is. It is it's easy to get wrong. So only really do this method if you are super confident, okay? Some of them are tricky. So if it's like a gradient of 2/3, that can be quite tricky to get right. So just be super careful with that. I'd maybe be more inclined to do the table method for that one. If it's a minus gradient, so if it's a negative, then it would be for every, say it was -5 here, it would be for every 1 you went across, you would go down 5. Okay, right, moving on. Let's look at example 3 then. So we're going to be finding the gradients of some graphs. Okay, now, if you remember back to the start, we went through the different methods for finding the gradients. I'm going to do this one here, but then I will also talk you through these two. It's just that this one here is like the best method really to use. Now, you may notice there's 2x all over my page. It's because I keep making silly mistakes. So let's hope we get it right this time. Now, this is already done because I did already start this and then notice I made a silly mistake. But the first step that you want to do whenever you're doing this is to pick 2 points on the line. Now, you don't want to choose really random points, so you wouldn't choose like here or here because they're not nice points. By nice point, I mean a point where your line is passing right through the grid lines on your page. So see how these two that I've chosen, they're right on grid lines, so I know they're exact numbers that I'm getting. So this was the first point I chose, and it's x1, y1, and this is the second point, and it's x2, y2. Now, underneath those labels, I like to write out the coordinates because it really helps me in the next step. So for here, the x coordinate is 2, and the y coordinate is 4. So now I know x1 is 2 and y1 is 4. For this one, the x coordinate is 12 and the y coordinate is 9. Okay, now, but I've said already, I do make silly mistakes all the time. Doing this does stop me from making silly mistakes. It just makes it easy for me to pick out the numbers whenever I'm substituting them into my equation. So, write out our equation for calculating the gradient. M for gradient is y2 minus y1 over x2 minus x1. Now all I have to do is substitute in my values. So y2, if I look up here, is 9. Take away y1 is 4. All divided by x2 is 12. Take away x1, which is 2. So 9 take away 4 is 5. 12 take away 2 is 10. I've run out of room here. So I'm going to have to work across here, but 5 over 10 is a half, or 0.5, or a half, either one is fine. Okay, now that's the first method. I'm going to show you the rise over run and the difference in the y coordinates divided by the difference in the x coordinates. That's basically, they're the same as each other, but I'll show you how I would lay this out. So if I was doing rise over run, I would still have to pick my 2 points, okay, and I would draw on a little triangle like this. Now the rise is really just the difference in the y coordinates, which is what we have figured out over here, so the mass is all the same. So this one goes from 9 down to 4, so the length of this is 5, and the run is the difference in the x coordinates. So this one goes from 2 to 12, so it's 10. So if I was doing my working out for that, this is part of my working out, these lines I've drawn on here, but I would write rise over run. The rise is 5 and the run is 10, so that gets me the 0.5. Now, this method did appear to be much quicker there, but in truth, it's just because I already had done the hard work. I picked out the points in this one here. So 6 of one, half a dozen of the other. Okay, let's look at B. So for example B in this one, we're going to do the same. So we'll have to find the gradient. Let's pick 2 points. So here's a nice one here. Let's call this x1, y1. And let's look at our coordinates. So the x coordinate is 1, the y coordinate is 10. And let's choose this one. So this one's going to be x2, y2. So for this, the x coordinate is 4 and the y coordinate is 1. So if I'm doing my gradient equals y2 minus y1 over x2 minus x1, I get y2 is, what is it, 1? Take away y1, which is 10, divided by x2, which is 4, take away x1, which is 1. So 1 take away 10 gives me minus 9, divided by 4 take away 1 is 3. So I get a gradient of minus 3. Okay. Now, if I was to do the rise over run method for the same thing, again, I would have to pick 2 points. Let's use the ones I've already picked. So I'm drawing on the lines just like I did the last time. Now, do you remember at the start I said, oh, you need to be careful if you do rise over run, because this technically isn't a rise, it's a fall. So going from 10 to 1, that is 9, and going from 1 to 4 is 3. So if I do m is rise over run, I need to be careful and think of the fact that this is going down the way, so my rise is actually a negative, so it's really minus 9, and the run is 3, which gets me the minus 3 value. And you can see how people make mistakes there. So lots of people would just put 3 for this, and that's why this method here really is the best method for getting your gradient, because it will always give you the minus as long as you substitute everything in right. Okay. Right, example 4 is to state the equations for these two graphs that we've just been looking at in example 3. So we need to think back to the equation for a straight line, which is y equals mx plus c. Okay, now m is the gradient. We've done the hard work already. If you got this question straight away, you would need to be doing all this then to find the gradient, but we've already done it. So for A, our gradient was 0.5, and then C is the y-intercept. So my y-intercept here, the point where it crosses the y-axis, is at 3. So 0.5x plus 3. And that's that one. Then for B, y equals mx plus c. So m is the gradient. Let's look back over at B. So the gradient in this one was minus 3. So y equals minus 3x plus c, the y-intercept, who's here. So that's 13. Okay. Example 5. Oh. State the gradient and y-intercepts of these lines here. So y equals 4x minus 2. The gradient, m, is the number in front of the x, so it's 4. And the y-intercept is minus 2. For this one, the gradient is minus 3. And the y-intercept is 7. This one here we need to be careful with, because this one technically isn't in the form y equals mx plus c, so we need to change it so that it is. So really, we need to get this to be just y on its own, so we have to divide both sides of our equation by 2. So 2y divided by 2 gives me y. 5x divided by 2 gives me 2.5x. 4 divided by 2 gives me 2. So the gradient of this one is 2.5 and the y-intercept is 2. And then this one here we need to be careful of, because if you look at this straight away you might accidentally say that the gradient is 3, but it's not, because look, it's not in the form y equals mx plus c. This one's technically written as y equals c plus mx. So rearrange it first of all to put the x numbers first. So y equals minus 2x plus 3, and that now does line up with y equals mx plus c. So the gradient in this one is minus 2, and the y-intercept is 3. Okay. Now, if you were asked to state which one of these equations was the steepest, for example, then you just have to look at the value of the gradient. Now be super careful, because say if you just glance down here, you would see this 5 and you would say this one's the steepest, but remember that was whenever it was 2y. So be careful to compare the actual gradients. So it's actually this one here is the steepest, the y equals 4x minus 2. Okay, I've rambled on enough, that was a long one. I will see you in the next video. Bye!